Whenever we open a website, the browser downloads and execute untrusted code from the internet, and that code runs on our devices. And if there are no restrictions, any website could access our data, and it can be any form of data. This sounds very strange, but like, are we not secure enough? And we would not be if there are no restrictions applied. So that's what we are going to look at, the restrictions that browser applies to protect the end user, and why modern browsers are preferred, and what are their built-in enforcement mechanisms. So we are going to start with isolation. Whenever we open different tabs and different websites in each tab, like opening a bank site or YouTube or a pirated site, how does it protect the data from other tabs? That's where multi-process architecture comes in. So instead of running everything in one process, the browser splits responsibilities into different parts, like UI processes, tab management processes, render process, network processes, and different kind of processes. So when the code comes from the server to the browser, it always treat as untrusted code. So what it would mean is that it would treat the untrusted data by running it inside a sandbox. So it does not have any direct file system or any OS level APIs or any elevated permissions, so that it does not have any access to other data, right? So running in a sandbox happen by using the OS level security features. Like on Linux, there is namespace and seccomp. On Mac OS, there is a seatbelt sandbox, and using these sandboxing, these isolation helps so that data isolation between each process is being intact. Next comes when you are inside the website, right? How will it prevent things in the browser, like preventing unauthorized JavaScript execution? So first of all, we are going to look at same origin policy, or we can say SOP. So it is browser's primary data separation layer. So first of all, the browser defines an origin by three things: the protocol, the domain, and the port. Protocol can be HTTPS, domain and the port. So to prevent two different pages from accessing each other data, like cookie or local storage, what it does is it checks through the origin of the executing script and the target resource. So if the origins are different, then it blocks the access unless it is explicitly allowed. Real world applications are split across multiple domains, like simply backend and front end resources. So it is not possible if SOPs were absolute with no exception. So modern web apps simply wouldn't function. It does follow a simple rule, like it blocks everything by default unless the server clearly says that it is allowed. So to control that, we have CORS. Here the browser checks whether the server has explicitly allowed that origin or not. So it checks if the response contain an header like access control allow origin or not. And if that header is missing, the browser blocks access to the response data. So basically, if the CORS is enforced by the browser so that it can protect users from other websites that are trying to read data that they should not. So it is about controlling who can read from where. But attacks are not always cross origin, right? Suppose if the attack is not from the another origin, what if the attack is from running code inside your own site, like XSS attack? Like, so how vulnerable can XSS can be. To prevent it, we have CSP, that is content security policy. This is about execution of code only from the trusted sources. This sounds safe because if you have seen a response header in any website, so there is a CSP header like content security policy, and it contains script source self. That means the browser should only run JavaScript files that come from the same domain as the website. So if you see another like default source as self, so it means that it should load resources only from the same domain unless it is explicitly allowed. So even if attacker is trying to do an XSS attack, which is very common, CSP can prevent it because it will only run those scripts that match the defined policy. That means injected script will not get executed if they are not allowed. Now comes a scenario when the user does not know whether and where they are clicking, whether it's legitimate or not. Like normally when one website allows another website to load data inside it, that's done using iframe. So an attacker can place an invisible iframe over a button, and when clicked by the victim user, it can perform action without user consent. So how does the browser prevent it? So there are headers like xframe options with deny, and using CSP with frame ancestors as none. So what would it do? It means that no other website is allowed to load this page inside an iframe. So now resource does not load inside that iframe even if an attacker tries to embed it. The browser will block it and the page will simply not open inside other sites. Suppose you are on a public Wi-Fi and you are accessing your data over HTTPS. So all the data is encrypted, and if something goes wrong, like expired certificate or wrong domain, the browser will warn you about it, right? But what if an attacker can try to downgrade the connection from HTTPS to HTTP and does an man in the middle attack? So that's where we can simply add an strict transport security, that's also called HSTS. So what it would do, it means that never to use HTTP for this domain. So there would be no downgrade from HTTPS to HTTP. Next is about user identity, and like cookies are used by the most sites. If you have seen, there are flags when you open storage section of in any browser, you will see different flags there, and it the mostly there are HTTP only, mainly HTTP only, and if it is marked there, that means JavaScript cannot read it. So even if malicious script runs on the page, it cannot access that cookie because it is blocked. And then there is secure flag. So if a cookie is marked secure, the browser sends it only over HTTPS. And SameSite flag. So SameSite flag controls whether cookies are sent in cross-site request. So it can prevent CSRF attacks. Just so it does that by preventing the cookie sending in cross-origin situations. So these were all the methods that we can use, like strict boundaries and execution, communication, and identity. So we can follow these security practices to prevent and use browser feature to strengthen the security of our applications, and the browser will restrict according to our policies. So this was about today, and see you in next one.